In this video, we'll use xpFluidFX and other dynamic objects to make this swirling splash animation. So let's get started. So here we are in the scene that we last left off. This is our sphere's base scene, which is cached, and we have our base spheres moving around nicely. So let's just, before we move on, let's just rename our first system, and we'll call it System Spheres Base, just so we're going to keep really organized. All right, and then we'll just hit save. So we save that change. And now we're going to start this as our new scene when we're going to start creating our water splash. And so to do that, we're going to save this into its own kind of project folder within our parent project folder. So we're going to keep completely organized and separate should we need to kind of go back at any stage. So let's just go to File, Save As. And here we are in my water spin library. So I'll just go back to my parent file, and we have our sphere base folder where we were saving all of those original scenes. So let's just get a new folder, and we'll call this 02 water splash. Okay, and we'll go inside there. Before we save this, let's do a new folder, and we'll make a cache folder because we will be caching at some point. Great. And then we'll call this 02 water splash, and then give it a version so then we can save incrementally. Hit save. Okay, perfect. So now we're kind of in our new project area, ready to build our new scene. So what do we need to do? Well, first of all, we're going to create our water splash with the water and the foam and all of the meshes and whatnot in a new particle system. So we'll keep our sphere's base system separate from our water one. So let's go to xParticles, System. Here's our new system. Let's do a couple of things before we move on. We'll go to the Object tab of that system object and take off the icon and viewport. Let's make this system blue for water. So the icon is blue. There we go. And very nice. So now we've got our default emitter has come into the scene. Let's just, I'm going to hold Control-Alt and make all of this invisible. So now we have this default emitter, and it is spitting out particles, and they're being affected by all of the objects that are within this system sphere's base. So to stop that from happening, let's go to our new system and let's look, tick only modifiers in same system. If we click that, these modifiers will stop affecting it. So none of the modifiers are affecting it, but look, this emitter is being affected by something, isn't it? And what it's being affected by, if we just open up our system sphere's base, it is bouncing off the inside of this sphere, look. And we don't want that to happen. So let's just go to that collider object of the sphere. Let's go to exclusions, and let's drag in our emitter. And now this emitter isn't interacting with anything within our system sphere's base, none of the modifiers or this collision object on that sphere. So now we kind of have a completely fresh system. Great. So we'll go to our emitter. This is going to be our water emitter. So let's do a couple of things. Let's rename it. We'll go to basic and call it emitter water. Let's go to the display tab. And we'll change the icon color to a blue one as well. So we know this is the water one. There we go. And we'll also change the display mode from dots to something like squares, so we can see them a bit more easily. And let's change the color of those to a nice blue color. So there are our water particles. Excellent. Right. So what we need to do is bring some objects in to start getting these to behave like fluid. So to do that, what we're going to use several dynamic objects. Some dynamic objects to get the movement so they're interacting correctly with our base spheres. Some dynamic objects to get them to start interacting with each other like a water body would. And then another dynamics object to create the splashy, foamy spray particles. So there's going to be a lot of stuff layered up to get this working. First of all, let's start getting the movement correct of these water particles. So what we're going to do is we're going to use a flow field. Let's go to Dynamics, and we'll go to Dynamic Objects and bring in a flow field. And by default, we get these vectors going in the plus Z axis, and it's set to a directional force. So what we're going to do is this. We are going to change this flow from default. Now, in the previous scene, we used a spline to get the flow of the particles. But this time, we want this water body to be really coherently moving with our base spheres. So what if we were to use the base spheres as the source of these vectors? Well, let's do that. Let's go to Particles. We're going to set the source of our flow field as a particle source. And we're going to drag in, let's unfurl our spheres-based system. Let's use our emitter-based spheres as the source. And look, you can see the vectors will change per frame depending on the position of those particles. And you see, look, you can see those vectors changing within the flow field. Fantastic. So let's make a couple of adjustments. We want this to be really strong. Let's put the strength way up. And we also want the flow field to be in charge of not only the direction of our water particles, but also the speed of how they are moving. So let's change the field from direction to velocity, which will obviously give us both direction and speed. And look, the speed is set to 200 by default. We'll leave it at that for now. Let's remove the fall off and let's hit play. What do we get? So look, you can see these arrows changing, and look what's happened to our fluid particles. Without any other modifiers in the scene, we're getting this kind of helix swirling motion, which is being driven by, let's just make these visible again, our base particles. So it's these fluid particles are now moving coherently with the way in which our base particles are moving. So that's really smart. So let's just make all of that invisible again. And we'll concentrate a little bit more on the movement of these new fluid particles. For this flow field, let's just make the flow field invisible for now. So we're getting the effects of it without looking at those vectors in the bounding box. So what we want is we want this to be a much kind of thinner sheeting water body. So let's do a couple of things. Let's get this emitter. We'll go to the object mode and let's just use the handle to make it a much thinner emitter. There we go. Let's have a look. That's better. So that's looking good. And obviously we can make finer adjustments when we're getting close to the point where we need this to interact correctly with our base spheres. But for now, we're getting the basic motion. So, but by making that a much thinner emitter, we're getting a thinner stream of particles. All right, so they're being moved around by our flow field. So now what we could do is we could start getting them to interact with each other like fluid particles, because at the moment they're not. So let's go to Dynamics. Let's go to the Dynamics menu and bring in an xpFluidFX and just leave everything on default. So now they're behaving a little bit more cohesively like a body of water. All right. So what might we do? Well, we actually want these to kind of hold their form together a bit more in droplets. So the way in which we're going to encourage them to be more kind of have more of a water droplet rather than separate entities is we're going to give them a little bit more of a surface tension value, which is what helps water form into droplets. So the way we do that, we access those settings in the emitter settings. We'll go to the extended data, and we are going to go to the fluid data tab. And in here we have all of the particle fluid settings. So what we want these to be very splashy. So let's reduce the viscosity, which makes water, give it that kind of stickiness. So we'll reduce the viscosity. We want to have kind of accentuated turbulent curls in this. So we can do that by increasing the vorticity amount. So let's put both the large and small to a fairly high number. And here's our surface tension. This is the key. This is going to help us make it much more kind of blobby, globularly water. And now we're going to have something that's going to hold its form. Now, we don't really have enough water particles for it to completely hold its form. We've got these gaps in our flow, and we're going to fill those gaps in with another dynamic object. Just before we do, let's just go back to our emitter water. Let's go back to the emission tab, and let's have a look at these particles. At the moment, we have got slightly too many per second. Let's put this down to, say, 600. We don't want to emit all frames, so let's uncheck that. We want to give the base spheres a bit of a head start. So let's start the emission on, say, frame 16, and we'll end emit on, we may adjust this, but let's just put 100 for now. And the speed, let's put the radius down to, say, 1. And we'll hit play. So there's our kind of water helix. So now we want to fill in some of these gaps, and we're going to do that with the xpSheeter object. What the sheeter object does, let's just bring it in. We've got a dynamics. We go to the dynamics menu, and we can bring in the xpSheeter. Now what the sheeter does, it's very clever. It looks at two fluid particles and the way in which they are moving away from each other or moving in relation to each other. And if the way in which they are moving satisfies the various settings and thresholds that we put here, it will spawn new particles in the gaps. So let's just hit play on the default settings. Look, you can see, look, we've already got loads more particles being born, and we've actually got too many being born. So let's just stop that. Let's bring this maximum hole size so it can only fill in very small holes, which will reduce the amount that it's able to make. Let's have a look. Okay, so that's made fewer. So let's then start increasing this max density, which will open up more for sheeting. Look, can you see that we're getting more and more swirls and tendrils being created? And now we're getting these tendrils of water, which is looking really interesting. And what we're doing is you want to push and pull these amounts until you've got the kind of shape that you want. Look, if we start increasing the max hole size, it's going to start creating lots more sheets. There we go. And we're getting these really nice, interesting tendrils. So what we will do is we will leave these settings here for now because we haven't got all of the motion of these particles sorted out yet. But of course we can return to these sheeter settings and the FluidFX settings whenever we want to make adjustments as and when we need to. But let's just leave them at this for now. So now what we need to move on to is to start kind of art directing this flow of swirly particles a little bit more. And we need to do that with some modifiers, and we can do it by bringing in some more collision objects as well. So we need to think about how this fluid is going to behave. It starts off by swirling out from the center of our sphere, just like our sphere base particles. But then what we need it to do, once it gets to the outside of the sphere and the sphere base particles, we need it to kind of to float on that spherical surface. It needs to look like the water is on the outside of our sphere base, and we need it to kind of stick to that surface and swirl around those spheres. So this is what we need to do. We need to create an additional sphere. If we just open our sphere base system. We need to create an additional collider sphere type object just for the water particles to kind of float on the outside and stay on the outside, and so our sphere bases are on the inside. So that is what we are going to set up. So what we could do is this. Let's take our sphere, which we used as our collider object in our sphere-based system. Let's hold Control, and we'll drag a copy of that into our other objects. So there's our new one. Okay, so we have the same sphere. And with this sphere, we want it to be a collision object, but we want objects, the water, to collide with it from the outside, not the inside, because we want it to kind of swirl around those base spheres. So let's go to this collider tag. We will remove the exclusion of the water particles, which was what we did with the other one. So let's just delete that. And in the tag settings, let's change the normals from inside to outside. Okay? Great. So what's going to happen is the water particles, because the normals are set to outside, they'll be allowed to come outside of this sphere, but they won't then be allowed to get back inside. And so they'll always be swirling around on the outside of our base spheres, which is really what we need. Great, so that's the first stage. The second stage is that, look, we've got this flow field force forcing these water particles round and around, and they're moving away from that sphere. And we want something that's going to attract them to the surface of this sphere, so they're going to kind of flow around it, touching it. So how are we going to do that? Well, we are going to use a modifier with a mode, a really underutilized mode, and it is the gravity modifier. But we're going to use it slightly differently than we would in a normal scene. So let's go to our modifiers menu, and we're going to go to our motion modifiers, and we're going to bring in a gravity. Now, by default, the gravity is just going to send these particles downwards. Now, it's not having a huge effect at the moment because our flow field is set to velocity, and it's the flow field that is giving them this movement. But look, as the particles escape from the bounds of that flow field, they then get pulled down by the gravity. But we don't want the gravity to be pulling them down. We want the gravity to be working a bit like a real-world gravity, where they're being pulled towards our spherical object. So the way we get that to work is this. We are going to go to the gravity object, and in the type, we're going to change it from standard, which is just an acceleration force, downwards, to Newton, which is a kind of it simulates a realistic gravity. So it needs an attractor. What is the mass? What is the body that these particles should be attracted to? Well, obviously it's going to be our sphere, isn't it? So let's put our sphere in there. And we've got lots of settings in our Newton gravity mode, which you can use to build and art direct fantastic orbiting kind of planet systems, which gives you a huge amount of control. But actually, we don't need any of those settings whatsoever for this. We just want them to be attracted to this mass. So what we can do is we can remove this limit force min, limit force max, and axis offset. Let's just take all of that off. We don't need this for our scene. I won't go into the detail of exactly how all of this works for this tutorial because it's not necessary. But if you want to have a look at those settings and get an idea of how they work, if you just come down to the bottom of any modifier, you can click on this question mark, which will automatically open the xParticles manual, and it will have a written description of all of these settings and what they do. So if you want to have a mess around with those, do refer to that reference and have a look. But for us, we don't need to. We just need this to have this attractor mass, which is effectively a strength. The greater the mass, the greater the gravitational pull. Let's put this down to, say, 8. So now what is happening is that we have this gravitational force, but it's going a bit weird because it's kind of fighting with the flow field. So we need to do something. We need to limit this to only happen outside of our sphere. So how are we going to do that? Well, the way we're going to limit this, look, at the moment it's just not working because that gravity is causing this kind of, there's multiple forces fighting with each other and it's not working. So what we need to do is this. We need to prevent this gravity from having any effect within our sphere. So it only happens once they get on the outside of the sphere. The way we will do that is this. Well, it's going to be a two-pronged attack. We need to limit the effect of the flow field. So the flow field is only happening inside the sphere. And we need to limit the effect of the gravity, so it's only happening on the outside of the sphere. So let's address the flow field first. We will go to the flow field object and we are going to go to the fall off tab and we are going to use a spherical field. So let's go to spherical field, and the spherical field, let's just bring it in slightly so that it's only working, the flow field is only going to work within this spherical field, and that spherical field is slightly smaller than our gravitational and surface sphere. All right, so that's going to work, and we'll just leave it at that for now. Good. So now we will go to our gravity, and now we only want the gravity to happen outside of our sphere object. So the way we'll do that is, again, we'll use a fall off, but instead of using a spherical fall off, which we could do, but we can also just use the actual sphere as an object, as a fall off object, which is really cool. So let's drag the sphere into our fall offs list. And let's click on the sphere. And there's a couple of things we need to do to get this to work. First of all, in the layer menu, we don't want it to be the points of the sphere, which are the fall off points. We want it to be the volume. Okay, good. And then we will go to the remapping tab, and we want it to be on the outside of the volume where this effect happens. So we need to invert the fall off. And then we can leave everything else default. And now what we should have is a flow field that's affecting them inside. And then as soon as they come outside, look, they're sliding around the surface of that sphere. And it's the gravity which is keeping them on that surface. Fantastic. Now we've got tweaks to make, but we are getting there. So just to recap what we have done, we have used this spherical field on the flow field to limit the power of that flow field to only affect the fluid particles when they're on the inside of our fall-off sphere. We have then got a gravity, and the gravity is using the sphere as a fall-off, but because we've inverted it, it means the gravity only works when the fluid particles are outside of our sphere. And as a result, the flow field makes us have this really nice kind of vortex of fluid particles. And then as soon as they come on the outside of the sphere, the gravity tries to kind of force them back in and they stay on the surface. So that is already looking really cool. The next step is to make this even more clever. And the way we're going to make it even more clever is we want these particles, as they're interacting with this surface, to kind of bulge a little bit as these base particles are moving around. Because at the moment, they're just moving around this static sphere, and they're not really respecting the internal movement of our base spheres. So what we're going to do is another trick to ensure that our fluid particles feel like they're moving across the surface of our base particles, even though they're not. And we're going to do that with a trick using a Cinema 4D deformer. So the deformer in question, let's get it set up. In fact, before we do, let's just get a little bit more organized, because our object manager is starting to get messy. So we'll bring our water system down. Let's rename this system water so we know exactly what it is. And also, just before we move on, we've got two systems now, and in each system we've got objects which are named the same thing. There's a sphere, a collision object sphere in both. So just so we're not going to cause any confusion down the line, let's rename that. So this is our system water, and it's our kaleidosphere, and it's set to the collide on the outside of the normals. So let's go sphere, water, outside. Okay, and then we'll do the same for the system sphere's base. We will rename the sphere base inside, because that's the normals are set to collide on the inside of this one. All right. Always try and stay organized as you're working through projects. The temptation is to fire away really quickly and bring loads of objects in and start getting your simulations working, but then it makes it so difficult to make tweaks further down the line, especially if you're working in a team of artists. Right, so what do we need to do? Let's go back to our XP system water. We have our geometry. Let's just go to the display tag and turn it off. So this sphere geometry is what our fluid particles are interacting with once they get outside of its volume, and it is the gravity which is pushing those particles to the surface, and then they're kind of making their way around. But we want this surface to mirror the bumpiness of the underlying sphere's base particles. So we're going to do that with a deformer. So let's go to the deformers menu, and we're going to use a collision deformer. Now the collision deformer, let's make that a child of the sphere. The collision deformer, if we go to its settings, it has a colliders tab, and here it wants geometry to measure whether or not that geometry is intersected with the surface of the object, of the parent object. So we need to make some geometry out of the base particles. So we'll do that using an OpenVDB mesher. I'm just going to switch off that sphere for now. So let's go to the generators tab, and we'll go to the menu and bring in an OpenVDB mesher. Let's bring that in. Now the OpenVDB mesher requires a source. What do you want to mesh? It could be a spline, it could be Cinema 4D geometry, it could be a model, it could be particles, it can be all kinds of things. It could even be an explosion, a smoke and fire volume simulation. But we're going to do particles. So let's just shut down our system water. Let's reopen our system spheres base. We want to make a mesh out of our spheres. So let's drag them into the sources. And we've got this huge mesh now. So why has it gone so massive? I'm just going to minimize that spheres base. Now we've got that object, and reopen our system water. So why is this so massive? Well, in the OpenVDB mesher, when we're meshing particles, there are two settings to keep an eye on. There is the point radius and the voxel size. And these are the two settings we'll make to adjust this mesh. Now, the point radius is it multiplies the radius of the particle of which it's meshing, and the radius of our particle is 1 centimeter. So it has made a 10 centimeter radius around each particle, and because that's such a big radius, it's just made this big blob. If we start reducing this down, you'll see it's getting smaller and smaller and smaller, to the point where we're starting to see those individual sphere particles. And now we have got this kind of blobby mesh down with a point radius of 1. Let's perhaps make that a point radius of 2. That's maybe a bit big. Let's go for 1.5. So now look, now we have got this wobbly surface. And if we hit play, this geometry can now intersect with the surface of that base sphere. All right. So let's switch the sphere back on, and in the collision deformer, let's rename our OpenVDB mesher actually, before we do anything else. Let's call it mesher. Let's call it collision mesh. So we'll go to our collision deformer, and in the colliders tab, let's drag in our mesh. Okay. And let's press play, and we should start getting some deformation. There we go, look. Now let's just make our OpenVDB mesher invisible. We're getting a little bit of deformation, look. You see it's wobbling as those spheres go over the surface, and it just means that we don't have a perfect smooth surface for our fluid particles to move along. These are going to move along with the same movement as our blobby particles. And if you want this to be a little bit more detailed, well, we can go to the sphere and we can create more segments. Let's put it up to say 70. And now we're going to have, it's got more detail to play with. Now we're going to have more defined blobs. Let's just hit NA to get rid of those lines. So now look, we're getting this deformed blobby surface, which is going to mean that our fluid particles will look like they're moving in the same way as our base particles. So that's a really neat trick. Let's make that sphere now invisible. We don't need to see it. So these little things make a huge difference in ensuring that our animation has this level of coherency. So it looks like our fluid particles are interacting with our base mesh particles. And that is what we're going for with all of these simulations with xParticles, especially when we're using these dynamic objects. Make it feel coherent, like it's all part of the same system. And by having this nice blobby interaction with this fluid, it's going to make a huge difference in the realism of our simulation. So that's looking really nice. Okay, so now we need to start offering a few more bits of kind of art direction to ensure that we're getting we're getting the kind of the fluid simulation that we want with a level of detail that we want. So we need to work on a few more bits and bobs, and that is going to mean making some tweaks with what we have already and using some additional modifiers to create a little bit more of an interesting movement with our water sim. So first of all, I'm not entirely happy. Let's just play this through. Now I think, got a feeling we've got a little bit too much aggressive sheeting going on. It doesn't look too bad at this initial early stage, but once we get around here, we're starting to get very, very heavy build-up of sheeted particles here, and it's becoming too much. What we really want is to maintain some of the nice kind of thinner tendrils with some big lumps, but we don't want this massive lumping around here. So it's very easy to sort out. We'll just go back to the sheeter, and what we could do is let's just reduce our max hole size down, which means it can only fill in smaller holes, and we'll put this down to say, I don't know, 6 centimeters, and even that's very small change is going to ensure that we don't have quite as heavy clumping as that gets to the surface. So yeah, look, there's far fewer particles there than there was, and we've got these nice, look at these nice tendrils. When these are meshed, these are going to give nice long kind of stringy bits of fluid moving along the surface. What's nice is it's nice to get this initial bit of movement, and then we'll get a secondary kind of wave coming up, which is going to look really nice in the final render, especially when we kind of retime it to kind of accelerate in this big lump of water. Here it comes. Look, we've got this nice lump of water moving in down here. And there it comes splashing up. Okay, so that's a lot better. I'm not pleased with that, but our water hasn't got an awful lot of kind of frenetic movement, and what would be nice is to make it kind of stay cohesive in these shapes, but just give it a little bit more kind of curly movement. And we'll do that with let's do that with a turbulence modifier. So let's go down to our modifiers menu within our system water, and we'll go to the motion modifiers, and let's bring in a what have we got? Let's bring in a turbulence. And this turbulence is, well, let's just use it on default for now. And let's see how it looks. So this is going to create a little bit more kind of random looking curly movement within our fluid. But the size of that turbulence is going to be a little bit too big. We want it to be, we don't want the curls to be very big. So let's reduce it down to, say, I don't know, 40%. The frequency is the animation of that turbulence, and we could reduce that so it's not moving quite as quickly. And let's ramp up the speed hugely, the strength, so we just get a real idea of what this turbulence is doing to this water. Now, this turbulence is only going to be affecting the fluid particles because, of course, our green particles are cached. So this is only affecting the fluid. But look at that noisiness, that kind of additional movement the turbulence is bringing to these particles. It's too much, obviously. It's completely lost some of that shape, but it's giving a lot more kind of nice frenetic movement. So let's reduce that strength down to, say, I don't know, let's try 20. And then to control this more, we don't want the particles, once they leave the surface, to fly away and the turbulent force to be greater than the gravitational force pulling them to the surface. So what we could do is we could create a fall off with this turbulence to ensure that we're still getting the majority of the particles flowing around the surface. But look, we're getting a much more kind of noisy, curly, frenetic movement in our fluid particles now. So that's looking nice. So let's just limit the effects of this turbulence a little using that fall off. So we'll go to the fall off tab. Again, let's use a spherical fall off. And what we want to say is we really want to increase this fall off. So we want the full power of that turbulence within the sphere, but then as the particles make their way out, we don't really want it to have much effect anymore. So I'm just scaling this down so this inner circle basically matches the outer circle of our collision object, and then it gradually tails off, and so outside of that turbulence won't have an effect. So let's just try that one. So we should have our nice turbulence now within the fall off, and then we're now, look, these ones are escaped, but then they're being brought back into the surface, and it's just bringing some really nice residual animation and making that water behave much more kind of in a sloshy type way. Okay, so that's looking pretty good. Excellent. And of course, these are all completely adjustable. So you can adjust the strength of the turbulence, the strength of the flow fields. You can adjust slightly the size of the fall-offs. There is so much artistic control here. You mess around with yours and tweak them until you've got the look that you are happy with. Okay, so that is our turbulent force. So now what we need to do, what makes water look great in xParticles is it's a two-stage process. You need to get the water animation right first using the FluidFX and the Sheeter, and that gives you these water particles. We will mesh these water particles with the OpenVDB mesher to create the kind of the water geometry. And then we want to make loads of splash spray particles which give it that sense of detail. So what we need to move on to now is creating the splash and spray and foam particles based on this FluidFX simulation. So what we're going to do is we're going to use another dynamic object, and if we go to the Dynamics tab of our system water system, we can go to the menu and we have an XP foam. So what I'm going to do, I'm just going to bring that into the system. This actually isn't going to do anything yet, because if we go to the foam object, or go to the object tab, it actually requires its own dedicated emitter to create these foam particles. So without an emitter, it won't do anything, because just before we set up that foam particles, let's just rearrange our water emitter a little to make it work a little better for us, because at the moment we've got too wide a stream of particles here, which means that they aren't particularly cohesive, and It's looking a bit kind of sparse at the moment here. So what we're going to do, let's just dolly in a little bit. We'll go to our emitter water, and we want to make this a lot thinner. Let's make it smaller. And then let's just reposition it slightly. So this orange box here is our original emitter for our base spheres. So let's just move it maybe slightly underneath. And just by doing that can have a huge impact on the look, shape and feel of a simulation, because we've got fluid solvers working here, and all of the particles are being born in different places now. But we've also got our flow field. If we just make those arrows visible again, we've got our flow field, which are forcing our particles around. Now, I've just activated my flow field again, and we can see the vectors. Now, this flow field's been driven by those base spheres. But you can see, look, it's actually quite sparse. The grid of these vectors is quite sparse. And that's because if we go to the flow field object and move up, our cell size is really big, so we haven't really got a lot of detail. So if we reduce that cell size, we'll have far more cells, obviously. So now we should get a little bit more detail, and they should follow that path a little bit more closely. So let's just make that invisible again, and we'll hit play. Now we're getting a nice move around here. That's working well. Good. That looks excellent. Let's just have a quick look at that flow field spherical field that we set up. So the flow field works within this spherical field until we get to this outer bounds where it's not working anymore. So what we could perhaps do, look, let's move the outer bounds of that spherical field so it's really close to the surface of the kaleidosphere. That's looking nice. Okay. So we made a couple of tweaks, and that's looking good now. I like that. Right, so now we're going to look at making our foam. So whilst we do that, let's just make our base spheres invisible. And we want to start making our foam. So let's go back to our water system, and we brought in our foam object, but obviously it's not doing anything at the moment because, as I said earlier, it needs its own emitter. Let's just hit pause. So we can just create an emitter, and it makes a new emitter here in our systems. Let's rename that immediately. Let's call that emitter foam. And we can change, let's go to the display tab, and we'll change the icon color to white for foam. We'll keep it particle color white, displaying dots. That's fine. All right. So let's now go back to our foam object. So there's two ways of creating foam and spray in xParticles. There are the crest rate. So this is depending on how curly a body of water's wave is. And there's also an air rate. And this is how hard water particles bang into each other, therefore trapping air and creating foam and air. So you've got that kind of thing. You've got crest and you've got air rate. And then there's two different types. There is foam, which is the foam that kind of lies on the surface of the water and is dragged around by the waves and the turbulence of that water. And then you have spray, and these are kind of like foam, tiny foam particles that escape and then move away from the surface as spray. So I'm not going to go through all of these settings and explain exactly how the foam object works for this scene. This isn't a good scene to clearly demonstrate what all of the different settings do. To demonstrate that, you're much better off using a kind of a more traditional kind of water body with waves and ripples. So this won't really demonstrate for you what all of these settings do. But actually, luckily for us, we can use a lot of the default settings, and we're going to get some nice foam and spray effects. So I'll go through a couple of these settings, the ones that we need to concentrate on. So first of all, I'm going to concentrate. I'm just going to take off the air rate. Just put that on 0. So all we're doing now is concentrating on the crest rate foam particles, the ones that are created when waves curl up. So at the moment, we're not going to get any particles until after 60 frames. So let's just see if that's the case. So we've got no foam particles, nothing's happening at all. Once we get past frame 60, we should start possibly seeing some if our default thresholds will create those particles. So let's have a look. So we're getting a few. Can you see a few white dots? So we are getting some particles on default settings after 60 frames. Let's put that back down to, say, 10. So these will start creating a lot earlier. Let's hit play again. And there we go. Look, on default settings, we're getting these particles created by the crest. Okay, very good. So we're going to change a couple of the advection settings. This is how the particles move effectively. So the buoyancy is how much they're likely to float on the surface of the fluid, but we don't really have a hugely defined surface in our scene because we've got these splashy particles. This isn't a kind of a steady body of water like a river or an ocean that's got a very obvious surface. The surface particles of our fluid are changing so quickly that actually it's not an awful lot of use to us. So we can just stick this down to 0. It's not going to make a huge amount of difference. The drag setting is how much those foam particles are pulled around by the movement of the water. So we'll just leave that as default for now. Now we have a spray setting of 40%. So what this means is it looks at the water density of the fluid particles. And if the water density of the fluid particles surrounding the foam particles is anywhere below 10%, it will create spray particles and they will be moved around away from the surface by this percentage. So if we put it on 100, all of the spray particles will be sprayed off and they won't be anywhere near the fluid surface. But we don't really want spray. We just want these foam particles to stay on the body of water and just add a little bit more detail. So we're just going to take that spray value way down and we're going to reduce the foam density. So basically we want most of the particles to be foam particles and they're going to be dragged along using this percentage. So let's have a look. What we want is these foam and spray particles born. They're being moved with that. But look, you see we've got a bit of a problem here. We're getting them colliding with the inside of our sphere. Why is that happening? Well, if you remember, if we go back to our system spheres base system, we have our sphere base inside collider object with a collision tag. And if we go into the exclusions, do you remember we excluded the water particles from this because we wanted the water particles to be able to escape to the outside of the sphere and then the gravity bring them out to the outside surface. So we also need to put our spray particles in here to exclude them from that collision. So let's go back into our system water and let's bring in our foam particles, stick them in. So now we shouldn't get those foam particles sticking on this inside surface here. Let's have a look. And yes, they're coming outside now. That's what we want. But obviously the gravity is then forcing them along that surface. But that's exactly what we want. We want this spray leaking out of the edges of this collider. That's looking pretty nice. Okay. So let's go back to our foam object. So the amount of crest particles is dictated by a couple of things. We have the crest rate, but we also have this min crest and max crest setting. And what this is saying is only fluid particles which have created a wave of at least 30% and at max 50% of the overall crest will create those foam particles. So if we reduce this minimum down a bit, we will get more foam particles because more are allowed in that calculation. And actually, look, let's reduce that maximum speed down as well, so slower particles can create foam. So let's hit play, and now we've got some foam particles being created. That's looking good. Very nice. All right, and let's just have a look. Are we... Go to our... I just want to check my turbulence to make sure that we have got our turbulence affecting on the inside. Yes, that's fine. So we've still got turbulence affecting. We've got them affecting a little bit these outside foam particles. So that is great. Let's leave this simulating on a bit. So because we get these foam particles kind of being created in and around the crests, it really accentuates the detail of this fluid sim and actually makes it look more detailed than it actually is. It's a really neat trick. You can do a relatively low resolution fluid sim, but really get some nice foam particles in there, and it brings out that detail. Okay, so let's finally, we'll go back to our foam. And what I'm going to do now is I'm going to just put the crest rate down to 0. So now we're not getting any foam particles because the crest rate's on 0 and the air rate's on 0. So nothing is creating them. So now we want to have a look at our air rate settings, which are the particles trapping air between them as they bang into each other. So let's put this onto 20. And what you're going to see is with these settings, we're not going to get any foam particles. So let's have a look. I'll explain why in a second. So we're not getting any. And it's because we have such sparsely populated fluid sim that isn't enough of an impact of those particles to be trapping the air. So what we need to do is reduce massively the impact thresholds, which are the defaults. For a big body of water, these maximum impacts default settings would be fine, but for us it's not going to work. So we're going to put the minimum impact to 0, maximum impact to 1, and we should now start seeing that now we've reduced that, we have enough impact in this very low particle count sim to start creating some particles. And here we can look, as they're colliding, we're starting to get foam particles. Great. Let's just try increasing that air rate to, say, 40. And we're starting to get some as they bang. As they collide, that's obviously causing an impact, so we're getting more particles colliding there. Excellent. So that's looking nice. So then let's reintroduce our crest particles. Put the rate at 40. Let's see what we get. All right, and now so we've got lots more particles being created. This is going to create more detail for our sim. And that's looking really good. Excellent. We're getting these really nice detailed particles which are being moved very, very closely to the movement and velocities of our water, and that's because we don't have any of those spray particles which are moving them around, and we have the drag set to 70, so they're being really pulled around by that fluid velocity. Excellent. So that's looking really nice and detailed. That's working fantastically well for us. Excellent. All right, so I tell you what, actually what we're going to do before we save this up, our simulation is running a little bit slowly as we were getting towards this amount, around kind of the 110 frame mark. And that's because we have an awful lot of foam particles now. If we just go to the, look, let's go to the foam emitter. We'll go to the display tab. Let's click on HUD and we can show HUD. If I click that, it's going to tell us how many we've got. Look, we've got 74,000 foam particles on frame 74. Let's just move this on a little bit further. And this number is rising rapidly. Look, over 100,000 foam particles now. So we've got an awful lot in there and it's jumping up all of the time. So we could perhaps reduce the rate of that a little bit. We perhaps don't need as many. Let's go back to our foam solver. And look, let's just put these rates back down to 20 on the defaults. And let's see the difference. So look, just remember this, on frame 95, we've got 150,000 foam particles. So let's put that up and it should be obviously far fewer. But we've still got a fair amount in the viewport. It's still looking pretty detailed. So let's get to that same frame 95. And yeah, look, we've got half the amount. Great. So that's obviously much better. It's running much more quickly. And I think we've still got enough foam particles here to provide the detail that we want. We can, of course, up this again when it comes to render time if we need to. We can resim it with a higher crest and air rate for more foam particles. But as we're building, let's just keep our playback nice and quick, and we will leave it at that on crest rate 20 and air rate 20. Okay, so we've got our base animation for our water splash. Now, obviously, there's an awful lot more to do here. What we're going to move on to next, before we even think about meshing this and getting the rendering sorted out, we are going to create a secondary splash. And this is going to be the really nice splash that kind of wraps right around the front of our sphere. And this will come in towards the end. If you look at our reference, it's the nice slow motion wraparound splash. And we're going to work on that and sort out how we can kind of art direct that splash in the next video.